Today's lesson is 1.2.2, and it is part 2, creating linear inequalities in one variable. If you haven't watched part 1 yet, please go back and watch that. It will be a really good review for you about inequalities and how to solve them. Our objective is to solve linear inequalities in context. We've already done this with linear equations. Now we're going to do word problems with inequalities. So let's start this out with some key phrases. These are phrases that you might come across when you are reading a word problem that are going to tell you what inequality symbol you need to use. So first we're going to look at phrases that will hint towards us using greater than or equal to. The first phrase is at least. So if I say that in order to get a special, you have to bring at least 10 friends, that means you need to have 10 friends or more in order to get a discount. Another example is no fewer than. So you can have no fewer than 5 people in a group. Means that you need to have 5 or more people because there cannot be fewer than 5 people. In other words, X would be greater than or equal to 5 people. At least as many and minimum are other key phrases for greater than or equal to. So you need a minimum of 7. That means 7 is the smallest amount you can have. Let's look at examples for X is less than or equal to a certain number. So let's say the teacher tells you you can have no more than 3 in the group. That means that the number of people in the group needs to be less than or equal to 3. At most means you can't earn more than that number. So if you said you can earn 10 points of extra credit at most, that means you can not earn more than 10 points. And another one is maximum, meaning that is the maximum amount or the most. There might be less, but there will not be more. Make sure you jot down those key phrases, and let's go on to an example word problem and create our inequality. My question asks me, Joe has no more than $50 to spend at the mall. He wants to buy a pair of jeans and some juice. If the sales tax on the jeans is 4% and the juice with tax costs $2, what is the maximum price of jeans Joe can afford? Now we're going to use the same process that we used when we were writing linear equations earlier this week. So the first step was to read the problem. Well, let's go through and let's read the problem again. Joe has no more than $50 to spend at the mall. He wants to buy a pair of jeans and some juice. If the sales tax on the jeans is 4% and the juice with tax costs $2, what is the maximum price of jeans Joe can afford? So, step 2, just like we did before, we are going to list the knowns. So right now, what do I know? Well, I know that Joe has $50. I also know that he wants to buy juice, which is $2. And I know that the sales tax on jeans is 4%. And I know that he can spend no more than $50. Well, if I go back to my key phrases, I can see that no more than no more than, means that x is less than or equal to a certain number. So that tells me that x, x has to be less than or equal to $50. Or not necessarily x. Let's erase that x. We don't know what x is. But I know that my equation is going to be set up to less than or equal to $50. Okay, now we've got to go through and list the unknowns. Step 3. So what is unknown to me right now is the maximum price of jeans Joe can afford. So I'm going to write that down on my unknown. Maximum price of jeans. All right, let's take that information that we have and move on to step 4, which is to create the inequality. Let's start out by writing a verbal model, as we always do. So, the jeans, price of my jeans, plus the tax I spend on my jeans, plus my juice, all has to cost less than or equal to the $50 that Joe has. I'm going to use that verbal model and create an algebraic model. So, the jeans. I do not know how much the jeans cost. That is my unknown, what I'm trying to figure out. My tax, I know, is 4%, or as a decimal, that's 0.04. But remember that right now is just 4 cents. I need to do 4% times the cost of the jeans. So we've got to put the cost of the jeans in there again. So I have my jeans plus 4% tax on the jeans, plus we need to do the juice. And we know that the juice costs $2. This all needs to be less than or equal to $50. We've created our inequality. So let's go back and write down step number 5. Step number 5 is going to be to solve it. So I'm going to solve this by first distributing, which in this case we actually don't have anything to distribute. So let's go on and combine like terms. Now remember, this x plus 0.04x is kind of like 1x plus 0.04x. So when I add 1 plus 0.04, I get 1.04x. Bring down plus 2, bring down our inequality symbol, and bring down 50. Next, I need to get rid of my constant, so I subtract 2 from both sides. 2 minus 2 cancels out. I have 1.04x is less than or equal to 48. And finally, I need to divide both sides of my inequality by 1.04. So that will cancel out on the left. On the right side, I am left with x is less than or equal to 46.15. I rounded it to 15.15 because there are 2 decimals when we're talking about money. 2 numbers after the decimal place. Okay, let's finish up our final step here. Step number 6 is to interpret in context, just like we had to do when we were solving inequations. We had to give an answer in context of the problem. So my problem here is, what's the maximum price of jeans Joe can afford? I found out that x is less than or equal to 46.15. So I would say the maximum price of jeans Joe can afford is $46.15. And that is my answer in context. If you need to go back and watch any of that, please do it. We will do another example in class tomorrow. And don't forget your quiz.